So now we are starting lecture 8 in our helicopter dynamics course, and today I am going to discuss some vibration terms which are very important and often used to quantify the amount of vibration in a system, and I am Dr. Ranjan Ganguly. Now one of the key terms which is often used to measure vibration is the so-called peak value. So the peak value of vibration is the maximum stress that a vibrating part will go through. Now, the peak value, like its name suggests, is essentially the maximum level your stress can go through. We will also see a peak value of a typical function such as x of t, but most often we don't use the peak value except in some special cases. We use a mean value. And suppose we have a response x of t, then the mean value of this response is defined by this definition here. And here you can see that this is essentially taking the function x of t, integrating it from 0 to t, dividing this result by t, and then letting t become extremely large in the limit. So this is how we can obtain the mean value of a typical function. So let's look at an example. Suppose I take a sine wave a sine t, which is a very typical and simple form of vibration, and we consider a half cycle which is 0 to pi. Then from the definition I would have a by pi 0 to pi sine t dt. A is a constant, so I have brought it out of the integral sign. Now this can be written as 2a by pi, and therefore it becomes 0.637a. So essentially the mean value of the sine wave is 0.637a and not half of a as some of you may have thought without doing this particular mathematics. So let us look at this physically. So here I have drawn a rectified sine wave. A rectified sine wave means that the negative part here has been flipped, so it's all positive now. Now in this case we can look at this value. Mean value would be 2a by pi and somewhere around 0.637, so that's marked here, and the peak value in this case would be a, so that's the peak value of the system where the maximum displacement would take place. Now in many situations we use a mean square value of x of t, and this mean square value is based on the square of the displacement. So you can see here x squared t dt being taken, again the same integral being used 0 to t 1 by t. So this particular measure is often useful because it is a mark of the energy of the vibration. So energy of the vibration is typically proportional to the square of the displacement. So again let us go back to our sine function. So we can see here that the mean square value, if we calculate it out, comes to a square by 2. Now very often we use a root mean square value, which is simply the square root of the mean square value. So in that case we take the square root of this x bar square, that is called the x RMS. So the word RMS is used here, meaning root mean square, and that is a by root 2. So this is a value which is also very frequently used in terms of measuring vibration, and all these values attempt to quantify the vibration level to some measure. Depending on your problem, you may need to change the particular vibration measure you are considering. Now finally, when you want to measure noise, which is very similar to vibration, you often use decibels. And decibels are defined as 10 log 10 P1 by P2, where this log is to the base 10. So this is a power ratio, P1 by P2. And realizing that power is proportional to the displacement square, we can write dB as 10 log 10 x1 by x2 square, and that then gives us 20 log 10 x1 by x2, because this 2 can be taken in front, and so it becomes 10 into 2. So decibels are very important in terms of measuring noise. You will often see that noise is classified in terms of decibels. So we will end this lecture here on some basic terms which we are frequently going to hear about in the context of vibration. And I'll return to my next video where we are going to discuss spring mass damper systems.